Hi guys, we are going to do a video about how to read a phase diagram. This is probably a brand new concept for you guys. This is the kind of graph that you would see on the ACT. So those of you that are considering going to a four-year college, you are the ones that are going to be taking the ACT, and this experience will help you with that. So before we get started, we need to know what a standard or the usual temperature and pressure is. So the normal pressure that we have right now is 1 atmospheres. ATM is called atmospheres, so 1 ATM. And normal temperature, so like just room temperature, we're thinking like anywhere from like 72 to 74 degrees or so, is 23 degrees Celsius. So keep that in mind, take that note, and you'll need to know that for some of the questions that we're going to do. Okay, so here is the exact same phase diagram that you have in your packet. I'm going to go over all of it with you. I'm going to show you how to read it, show you how to answer the questions, okay? So here, the title, it says phase diagram for mysterious compound X. At the bottom, you see temperature. On the side, you see pressure. So we are going to figure out, as temperature changes and pressure changes, what state of matter is this mysterious compound X going to be. So you see these labels, solid, liquid, and gas. If I didn't give them to you, the solid would be the left and highest most side. The gas would be to the right and the bottom most side, and then the liquid would be in between. Okay, so solid to the left, gas to the right and down, and then liquid would be in between. Okay, so I'm going to label some things on the diagram for you. So first it says, what is the critical temperature of compound X? The critical temperature, so if you have this line, it's going to be separating solids from gases. This line is going to separate solids from liquids, and this line is going to separate liquids from gases. You find this line that's separating the liquid and gases and go up to the very top. That dot right there is called critical temperature. So the definition of critical temperature, the very highest temperature that a substance can exist as liquid. So if the temperature got higher than that, it would only be able to be a gas. If you look here and go down, that is about what, like 780 degrees Celsius. So if this mysterious compound X was raised to a higher temperature than that, it would reach its critical temperature and it would only be able to exist in a gas form. Okay? I'm going to go through your questions here and just keep answering them and showing you how I'm figuring them out. So, next question says, if you were to have a bottle containing compound X in your closet, what phase would it most likely be in? I'm going to say in my closet that it is at standard temperature and pressure. We need to remind ourselves that standard temperature and pressure is pressure at 1 atm and temperature at 23 degrees Celsius. Okay, so you should have that written down somewhere. And so I'm going to go at 23 degrees Celsius, so about a quarter of the way between 0 and 100, so about right here. And we're going to go at 1 atm. So 1 atm they don't show on this graph, but I know it's going to be below this, right? So it's going to be down here. So this area here, this whole area here, is a gas. So at standard temperature pressure, a bottle sitting in my closet is going to be a gas. Number 3, at what temperature and pressure will all three phases coexist? This is another definition that you need to know. Okay, so I have highlighted the 3 segments of the line for you. There's an orange line separating solids and gases, a green line separating solids and liquids, and a yellow line separating liquids and gases. So where those 3 meet in the middle is called the triple point. This is a one single point of temperature and pressure that all three states could exist. Okay? If I have a bottle of compound X at the pressure of 45 atm and temperature of 100 degrees Celsius, what will happen if I raise the temperature to 400 degrees Celsius? So these are the exact kind of questions that you would have on the ACT. You are going to find 45 atm. You're going to go over to 100. That's right here. And this is currently a solid, right? It says, what would happen if I went to 400 degrees Celsius? 400 degrees Celsius is right here. So you're going to cross that line. And like we said, that line is representing sublimation. So what will happen? Compound X will sublimate. It will sublime. It will go from a solid to a gas. Question number 5 says, why can't compound X be boiled at a temperature of 200 degrees Celsius? So if we go to 200 degrees Celsius, we can find that at low pressure, it's a gas. At high pressure, it's a solid. In order to boil something, we would need a liquid, right? So the reason why we can't boil compound X at the temperature of 200 degrees Celsius is because it's either a solid or a gas. It is never a liquid, so we can't boil it. Number 6 says, if I wanted to, could I drink compound X? Why or why not? Well, we got to go back to that standard temperature and pressure. Standard temperature and pressure, remember, was right here. And what kind of thing is it right there? It's a gas. I can't drink compound X because it's a gas. Okay, so you still have the back of this worksheet, and I'm going to let you do that on your own. I will help you if necessary. The questions are very similar. The graph itself, you actually have to make the graph. Okay? So let me give you a couple pointers really quick. 3 different data tables, and you are going to graph all 3 of those data tables. Okay? That's going to give you those 3 little lines. Remember those 3 sections of lines? Each of these data tables is going to give you a section of a line, and then if you notice, they give you the triple point. They tell you where they should intersect, and they also give you the critical point. They tell you where that liquid line should end.